All right. Okay, so let's start off by using summation notation to write the sum of a sequence whenever we're given some of the terms, and then we'll find the sum of that sequence. So we're given 3 plus 6 plus 12 plus 24, and so on, all the way to plus 192. Okay, so this is a geometric sequence, so I know to find the sum, I'm going to end up needing, the sum is a sub 1 times 1 minus r to the n over 1 minus r. So looking at this sequence, do I know what a sub 1 is? What? What is a sub 1? 3. And then how are these changing? What's the rate at which they're changing? 2. So that's everything I'm going to need, or not everything, but that's almost everything I'll need to find the sum. Let's actually try to write the sum. I'm going to go from 1 to, this is the part I don't know yet. Okay? It's more of a bubble. That's not a 0. But I do know that this is 3 times 2 to the n minus, or, I'm sorry, to the I minus 1. Okay, and just as a reminder, like, if you want to check yourself with this part right here, you could just plug in the terms. 3 times 2 to the 1 minus 1, well, that'd be 3 times 2 to the 0. To the 0 is just 1, so 3 times 1 is 3. The first term is 3, so that works out. Okay, so here's what we need to focus on, is that we don't know what term in the sequence 192 is. There are a few ways that we could do this. We know that it just doubles, so we could just figure out how many times we had to hit times 2. Right? Or I could go to y equals and type in 3 times 2 to the x minus 1, and then look at my table. Once I find 192 on the table, that x value is going to be the number in the sequence that term is. So whenever we look at our table, we find that 192 was the 7th term. So there are 7 terms in our sequence. I can use that, jumping back over to find the sum. So I've written it using summation notation. Now I want to find the sum. The sum is equal to the first term, 3, times 1 minus my rate, 2 to the n. What was n now that we found it in the calculator? 7, all over 1 minus 2. And the sum comes to 381. Alright, now to infinite sequences. To find the sum of an infinite sequence, the sum, so in summation notation, it would be from I equals 1 to infinity of a sub 1 times r to the I minus 1 is equal to a sub 1 over 1 minus r. Okay, but we have to note, if the absolute value of that r is greater than or equal to 1, the sum does not exist. Okay, it would just keep getting bigger and bigger and bigger and bigger, and so it would just become infinite, and it doesn't converge to a number. All right, let's consider the infinite sum of 4 times 0.6 to the n minus 1. I know it's an infinite sum because it goes from 1 to infinity. Well, all I need to know is a sub 1, and what's a sub 1 in this case? 4. And what's the r? 0.6. So to find the sum, that is just a sub 1 divided by 1 minus 0.6. So if we added all the terms in the sequence from 1 to infinity, it would equal 10. Okay, finally we're going to look at the series 3 plus 0.3 plus 0.03 plus 0.003 plus on and on for infinity. So whenever we're looking at this, we can pretty easily see that it's going to be 3.3 repeating or 3 1/3. But we're going to let that formula tell us that. So I need to know a sub 1, well my first term is 3, and the r I can find by taking the second term divided by the first, 0.1. So the sum is equal to my first term divided by 1 minus 0.1. As a fraction, this will come out to 10/3, or 3 1/3, or 3.3 repeating. That's how we'll do the sum of infinite sequences.